Hello, I'm Angela Aguero, and welcome to Respiratory Physiology Activity Lab. Today we are going to be going over the pre-lab questions, pre-lab assignment, and yeah, let's jump right into it. So basically, question one goes over different types of lung volumes and the baselines and liters, and we're going to talk about how we can get other volumes from other derived lung volumes. So question one, it asks for the inspiratory capacity, and to find the inspiratory capacity, you have to add the tidal volume and the inspiratory reserve volume, and in this case, the tidal volume is 0.5 and the IRV is 3, so you add 0.5 to 3 and you get 3.5 for the inspiratory capacity. And then the next question asks for the expiratory capacity, and it's basically the same idea. You have to add the expiratory reserve volume to the tidal volume, so 1 plus 0.5, and then you get 1.5. And then for the third part, it asks for the vital capacity, and basically to calculate the vital capacity, you add the ERV, the IRV, and the tidal volume. So you add 3, 1, and 0.5, and you end up getting with 4.5 liters. And for question 4, it asks for the functional residual capacity, and to find this out, you have to add the ERV to the residual volume, which is 1 plus 1.2, and you end up with 2.2. And question 5 for the part 5 for the first question asks, why does residual volume exist? And basically, residual volume measures all the volume after you expirate, and you can't get rid of all the oxygen in your lungs or gas exchange in your lungs because your lungs will actually collapse. So there has to still be some oxygen and carbon dioxide in your lungs, even after in between expiration and inspiration. So moving on to question 2, we have respiratory parameters and then their baselines and then what happens when it's obstructed and restricted. So for question 1, it asks, describe the key changes in obstructed lung volumes and function versus baseline values. So for question 1, basically, when we look at the obstructed pattern, the forced expiratory volume for 1 second is much lower than the forced vital capacity, which then changes the percentage ratio, which originally was 89% for the baseline, but then it goes to 60% because there's a big difference between the two numbers. But then for question 2, when you look at the restricted pattern, both the forced expiratory volume for 1 second and the forced vital capacity both decrease proportionally in the same way, so it doesn't actually change the baseline. So the baseline was 89% for both values, and then the restricted data is also 89%, so it doesn't get changed. Then moving on to question 3, which is, would you characterize asthma as a restrictive or obstructive disease? Well, the difference between the two, a obstructive lung disease is basically when you have a hard time exhaling oxygen out of your lungs, and then a restrictive lung disease is when you have a hard time inhaling, like fully expanding your lungs and inhaling oxygen. Asthma, I think, is considered a obstructive disease because a lot of my friends have asthma and they have a very hard time breathing out the air that they have inhaled in. So yeah, I've considered it an obstructive disease because they have a hard time breathing out and fully getting all the CO2 out of their body. So for question 4, it asks, would you characterize fibrotic lung disease, which causes lung tissue to stiffen, as a restrictive or obstructive disease? Why? So based on the question, a fibrotic lung disease stiffens lung tissue. So what I would say is that that disease would be in restrictive disease, because if your lung tissue stiffens, it's going to be hard to have gas exchange and current for your lungs to fully expand when you're inhaling. So I'm going to go ahead and say it's a restrictive disease. So for the final and third question, it asks, why does breathing into a paper bag help someone who is having a panic attack? Now, I've had personal experience with this question, so I can definitely answer it. So basically, when you are having a panic attack, you're breathing out all of the carbon dioxide in your lungs, which is carried with acid in your blood, which is not a good thing, because if you're breathing it all out, then that changes your pH of your blood in your body, and it makes your blood more basic, and this will throw your body out of whack and it's dangerous, and that's actually what causes you to pass out. So by breathing into a paper bag, you're breathing out all that carbon dioxide, but you're actually breathing it back in, like, so you're breathing it back in, which then starts to bring your blood pH back to an acidic level because you're not getting rid of it. So you're kind of like recapturing it and reusing it, if that makes sense.
Ryan,
So yeah, that's basically why you should breathe into a paper bag when you're having a panic attack. Learn that multiple times. So yeah, those were all the questions for the respiratory physiology activity. I will be making a TikTok to demonstrate one of the questions that was involved in that. I hope you enjoyed, and yeah, thanks for attending my little class.